So we are starting with our first keynote of the conference. The talk is by Professor Vijay Varadharajan. He is Global Innovation Chair Professor in Cybersecurity, University of Newcastle, Australia. He will be giving a talk on data-centric security. Professor Vijay has a strong leadership and management skills with extensive international experience. He is an experienced chairperson with a demonstrated history of working in both industry and academia. He has served as a senior professor and senior manager in the technology industry. With over 30 years of research and strategy experience gained in the UK, USA, and Australia, he specializes in cybersecurity, cloud computing, secure distributed systems, software security, malware, the Internet of Things, and big data security. He is also a highly qualified education professional, having graduated from the UK and INSEAD. Sir, I request you to start your keynote.
Okay. First of all, good morning. I'm delighted to be here. I would like to thank Dr. Sunil Bupakula for kindly inviting me to this conference, and I'm grateful for that. Look, today my talk is entitled Data-Centric Security. So what I thought I will do is first start with the technology scenery, and then look at cybersecurity briefly there, and then move into data context and perspectives. But my real focus of this talk is the third bullet, which is the data-centric security. That's where I'll be spending most of my time. And then I'll just conclude with some remarks in the end. Okay, so when I look at the technology scenery, as the chair just mentioned, I've been around in the cybersecurity space for over 40 years now. In the UK, US, and Australia. And I'm grateful I've had a chance to work in many of these fields that I've got here. But I see a technology scenery as, we got different types of networks, whether fixed networks, mobile networks, ad hoc networks, wireless networks, and so on. And then we got distributed systems that's, we have distributed services, cloud infrastructure, so on. Web services, service-oriented architectures. Then we have small devices to large-scale data centers. So we have small devices, sensors, IoT, to large-scale data centers, grid computing, high-speed computing systems. And then, of course, we have mobile software. The distributed applications and services are fixed distributed systems and software, whereas mobile applications, they move around, mobile agents, apps, and so on. And then we, of course, are one distributed databases, and I've singled out social media networking here as a particular class of applications. So all of this, there are security, privacy, trust requirements. So the technology infrastructure ecosystem is this spaghetti of various different technologies, network, software, stacks, so on. But the objective usually of a technologist is to be able to provide information that is really accurate, reliable, trustworthy, so that users and applications and services can make reliable decisions, dependable decisions. So when I say users, yes, we have individuals, but also small, medium enterprises, big corporation, government agencies, and of course, lots of applications and services, right, in a distributed systems world. So that's the sort of the spaghetti of technologies ecosystem that we are dealing with. And this is where security, privacy, and trust issues come in. Trust, security, these issues come in every bubble that I've got here, mobile networks to distributed systems and so on, but also they come in integrated solution, because at the end of the day, as an architect, as a technologist, cybersecurity technologist, you're supposed to provide a solution for the users so that they can have reliable access to information to make decisions, but underneath you get all this variety of these technologies. So this end-to-end solution is often necessary for the architect to develop solutions too. So now within this context, In my 40 years, basically, these are the technologies that I've been able to work with. In many of these, gets my hands dirty. But in the last decade, I would say, probably just over a decade, there are three areas which have come up to be major players. One is, of course, the cloud infrastructures and services, and then the IoT and cyber physical systems, and then the big data, and now which is coupled with AI systems. So these are, and again, there are security privacy requirements in each of these bubbles, in these circles, in the Venn diagram type figure you see here, but also at the intersection. Because often, new techniques, new solutions, novel ideas, novel prototypes, novel startups tend to happen at the intersections. Because, for instance, you might be taking data from IoT devices and cyber physical systems, and then you may be using cloud services infrastructure to store this data to do some processing. And then you will have business applications and AI-based reasoning applications running on the cloud to make business decisions. So it is at the intersection of these three areas which often results in business solutions or even new startups and new opportunities. Okay. Just a couple of slides on what I think security is before going to data-centric security. Security, although we talk about technology quite a bit, but security I see it as four pillars. There is of course, the technology angle pillar, and then the business angle. Different sectors will have slightly different requirements, different constraints, and different policies. And then there is the social angle, social aspects, how the security systems are being used by the society and what implication consequences there are. And then there are, of course, the legal angle, quite a few aspects of legal things, whether it is to do with mandatory data breach, to encryption, to, nowadays, lots and lots of legal aspects come in, especially with privacy and trust, and as well as security. So cybersecurity has got all these four pillars. Although we tend to, as a technologist, we tend to spend a lot of time on technology issues, it's critical that we understand, as a technologist, we understand the sector, the business applications that we are working for, and the implications it has got for social and legal purposes. Yeah. Last slide on the intro. Often security people, even seasoned security professionals, tend to confuse certain things. So I thought I'll set the baseline here. The security is about often owner of information having control. So security is not privacy. Privacy is the subject of information has control, and privacy requires security. Anonymity has no subject. It requires security and guarantees privacy, but it is neither. So what I mean by that is, let's take an example. So if you take a healthcare system, for instance, in the healthcare system, as a look at patient data. So I go to a hospital and I get some tests done, radiology scans, or some X-rays done. And these data are stored in the hospital information system. And the owner of this hospital information system is the hospital administrator, the hospital. And therefore, they have the obligation to provide security, that is, to ensure my data is secure when it resides within their system, when it is being used by users within their system, in their system. And security is not privacy. Whereas when does privacy matter? Privacy comes in if the subject has control, that is, who is the subject? With respect to this X-ray information or blood test, I am the subject, because the X-ray is about me, the blood test is about me. So the subject, if I am given the control in terms of modifying the data, looking at my data, ensuring who can access my data in the hospital information system, I can specify policies. This consultant can see it, this person cannot see it, so on and so forth. I get a say in this, then that system has privacy. And in order to achieve that privacy, in order to achieve these types of things, we need security mechanisms. Privacy requires security. Anonymity, in which there is no subject. So in the sense that, in principle, There's no principal or a user associated. When I say principal, it is an authenticated entity or a user, for instance. There is no subject associated with it. And it requires security, guarantees privacy, but it is neither. And typically, when you think of anonymity, let's say if I go and buy a pizza manually, or in a shop, I might just say, let's say I'm paying cash, and the guy who's giving me the pizza, he doesn't care about whether it is Vijay or John or Jane, whoever it is. The only thing he may care about is whether he gets the $10 or the $20, whatever it is. So in that sense, there is no subject in the sense of the user, but there is no, it is an anonymous transaction. In the internet, funny enough, although, in principle, getting theoretically fully anonymity is quite a difficult challenge. It is, there's a theoretical result which will tell you if getting full anonymity is actually quite difficult indeed. But whatever it is, it requires security mechanisms and it guarantees privacy because there's no subject. But it is neither security nor privacy. So having said that baseline, let me go to the data context. In the data context, so we know pretty much we are sharing data. There are users share data amongst themselves. We share data with devices. And of course, more importantly, devices and applications and services share data. In fact, that is probably where large amount of data gets shared in the third category. Now, many CIOs and CISOs and CTOs over the last decade, whenever you go to a conference or an industry forum, stuff like, they'll say, oh, data has become the new currency in the digital world. Oh, probably true. Probably true, but let me just pose a question. We'll come back to this question later on in the talk. Let me just pose a question. If data is become the center of the digital world, which it is true, then we should be able to do something like this. I should be able to sit on the terminal in my PC, laptop, iPad, mobile phone, wherever it is, and I can say, I should be able to ask a question about data. For instance, I should be able to ask the question, who has my credit card, for instance. As of now, if you try to sit down with your laptop and ask that question, you won't get an answer. Because at the moment, the infrastructures are not geared to answer these types of queries. So if data has become the new currency, that means it has become a primary construct in the language we are going to use, we should be able to answer these questions. So this sets the seed for what I mean by data-centric security. We'll come back to that later, but that's what I'm trying, the infrastructure, future generation infrastructure, there are some currently in there, which are dealing with this type of issues where we would be able to focus on the data itself, not necessarily on the container where the data gets stored. Okay, so looking still at the data context, we all know we use lots and lots of data. I just picked up some of these figures recently, 3 billion online users in the last 10 years. We'll add lots and lots of data, whether it is YouTube, social media, and so on. Some other interesting thing, all movies that have been made to date is probably about a petabyte or so. All music recorded to date is also about a petabyte. So if you want to capture everything that you ever said, from the time you're born till the time you die, it is less than a few percent of petabyte. Everything you did or experienced in living color is a few petabytes. Yeah. So that gives you a sort of a perspective how much data we need. So this effect, of course, changes the business models, right? Because whether I store the data, use the data locally, whether I have its cloud server and all sorts of, this like pendulum goes back and forth, whether, from the terminal, everything else is stored centrally or from locally and so on and so forth. But this gives you an indication of roughly the type of data we are dealing with, amount of data at least. So what has happened, if you look back in history, little bit. Previously, I don't know, 20, 30 years ago, default position was information was private until you opened it up. But now in the cyber world, pretty much everything is open. And the thing is, you got to close the thing. You got to ensure, you got to set your privacy settings in the social media or applications and so on platform to ensure that it is not always open. So the presumption has changed from one of controlling the opening to controlling the closing. Yeah, that is with respect to what is private. What is public? If one looks at what is public, previously one did something in public and few people saw it, sure. And they may share it with other people, they may put it, Whereas now in the cyber world, pretty much everybody has got a mobile phone or something, they can capture the data and they can share it. We all know that. So in fact, when we used to think George Orwell, he imagined government operating telescreens in our houses and looking at everything what we did. In fact, now it is much worse. Furthermore, the data what we have now may not be forgotten and may be recalled, may be aggregated by different people at different times. So so what is public is now, the perception is completely changed compared to 20, 30 years ago. So having said this, so data is important. Data will be, if you take data-centric approach, you will need to have data as a primary construct. And and the security, privacy, and trust issues with respect to systems and services have got to be tailored around this data-centric approach. And that's where I'm going towards, okay? So there are a lot of data-related challenges, several issues, questions, where does the data come from? Data provenance, how trustworthy it is. We got to define trust models. How do you know where your data is? Do you know who can see your data aggregated? There's all a bunch of questions. There are lots and lots of projects and work, solutions, techniques we can do based on answering bits and pieces of these questions. And this is typically, sorry, I want to say one more thing. That is, in these, when we do answer these questions, nowadays the elephant in the room obviously is machine learning or AI or deep learning algorithms, and they are heavily dependent upon data, as you know. So so data, at least at a high level, in these algorithms, neural networks, or deep learning or machine learning algorithms, typically data comes in when you train it. So data at training time, and also data in testing time. So, and there are attacks possible both at training and testing time. So this is one instance where data gets used heavily nowadays as well. So these questions, when we ask, where does the data come from? Who can aggregate it? What is your data? Is all equally applicable to machine learning systems as well. Okay. So in machine learning system, data is significant because slight modification of data can lead to pretty much completely different answers. So this is typically the area of adversarial machine learning. And this is one of the areas we've been working on for the last decade. But, for instance, slight, let's say you see a school bus there. And so this is a paper which was published in ICLR in 2014. So school bus there and, adding noise to it, although our eyes can recognize that this is still a bus, but machine learning algorithm, tends to, shows it's an ostrich or it's a bird. So clearly the modification of data is significant even, in the machine learning context, yeah. Okay, so having said that, now what I want to do is let's look at typically what do the users and the different players in the ecosystem, what do they want with data? Users, they want to have control over their data, and the control is a very elusive word, because even if they don't want to exercise control, they want to feel this control, right? They want to say they think they should have the control, even though they may choose not to exercise it all the time. That's typically a user behavior. And they want agents, the entities which process their data, to be trustworthy. So they only want organizations or servers or hosts in those organizations, they only trusted entities to process their data. From a regulator point of view, generally, there are these regulations such as GDPR or the California Consumer Privacy Act, which says data, control of data is a fundamental right, human right, and there are some mandatory rules and regulations associated with it, such as if the data breach happens, you've got to do A, B, C, and so on. We'll look at GDPR a little bit before going into the data-centric security. From an industry perspective, often what industry wants is it wants consistent rules. Because once it knows the rules, it can change its behavior, whether in building the relationship, whether how to comply to these rules, but it wants those rules to be consistent and somewhat stable, not dynamically changing every other day because it doesn't know how to behave. So that is, it want to take away the uncertainty. So they want consistent rules often. That's what the industry often looks for. Of course, industry is also not interested, is interested in less regulation generally, right? Because they think they can self-regulate more. It doesn't depend on whichever sector you go to. They will still say we can do our own self-regulation. But generally, they are looking for consistent rules. Yeah. So I want to take a couple of minutes about GDPR because that sets the scene for data-centric. And GDPR, I'm not going to go very much. I'm just going to hand wave. Basically, GDPR talks about personal data. Personal data can be anything, location, biometrics, so on, user ID, IP address, so on and so forth. And it applies to, if you're processing data within the EU, you're subjected to GDPR, of course. And similarly, if you're processing data belonging to a EU resident, even though it is outside of the EU, you're subjected to these regulations. There's a huge set of regulations, which you probably know. And there's compliance issues. If you do not comply, there are punishment and fines and so on. But also there are obligations issues. It says if you find out there's a data breaches, then you have to do these notifications within a certain period of time and so on and so forth. There's lots of rules and risks associated with it. From our point of view, data-centric approach point of view, the thing we are interested is this individual rights. What is the GDPR? I just want to say, because this is important because it tells you why we need a data-centric approach, taking GDPR as a way of saying this, it is, if you want to satisfy GDPR, data-centric approach is probably the best way to satisfy that. But here it says, GDPR is will say the user has the right to know about how his or her data is processed, right to see who has stored your data, right to have withdraw consent, right to have data erased, forgotten. Also, there are a bunch of these things. That's all to do with who stores, who aggregates, how long it's stored for, when should be deleted, so on and so forth. Taking that as the cue for data-centric approach, what I want to do is I want to talk about two distinct things. One is how data gets propagated in the internet world, what we can do, and I'm going to take only one problem, find where the data is and limits its use. That's one problem. The second thing I want to take about is data access control. I'm going to use those two things to explain my data-centric security approach. Yeah. So let's take the first one, find where the data is and limits its use. This is a typical requirement in GDPR, as you saw in the previous slide. Okay. So I need to be able to track sensitive data. And that's the example, for instance, I gave you before when I started, who has my credit card or who has my social security number or Aadhaar ID, so on and so forth. That's the typical instantiation of that question. And we need to do that over the whole internet. It's all right to do it within an organization or even between organizations, a large corporate organization, subsidiaries, but ideally we would want to do it over the internet. And we need to be able to track, for that we need to be able to track data at any time and see and look at who's doing what, which agent is processing. Let's take that problem and let's see how we can develop a solution based on data-centric approach. So the data-centric approach, the first thing is you need to have data tagged with some metadata which talks about the policy associated with the data. And the policy and the data, the metadata, should be tightly coupled. So in other words, you should not be able to separate out the two. Let's take that as a first step. And then we will say, okay, we need to say something about the agents who are going to be processing this data, right? Or what assumptions we are going to make. And then we need some policies. The user, the data owner, will be specifying some policies as to who can use the data, how the data can be used, so on and so forth. There are different types of auditing policies, tracking policies, obligation, access control, so on and so on. There are a variety of policies we can write, okay? So let me take a very simple scenario and let's take the data tracking protocol, which allows the data owner to track the flow of their data, Okay, this might happen in a number of scenarios, data from IoT devices, data in social media, lots of scenarios. This is one of the simple requirements, basic requirements we might have. Okay, so in order to do that, let's do a small architecture. Let's do, so we have our agent, the user's agent, and then user's policy, which says who can do what, and then there is the processing agent where the data gets processed. Let me show you a diagram. So we have data originator A, and he or she sending it to B, a processing agent, and very simple, and there's no security here. So first the user A sets his or her policy in his or her policy server, and basically it says like if this data ID can be processed by this agent ID or not, process ID or not, processor ID or not, yes or no. Very simple rule-based policy server. And A sends that information to B. A sends information data ID, in step 2, sends the data. And if you look at a protocol, a simple protocol will be, he sends the ID of the data plus the data, and then he sends the URL of the policy server. So the policy server is owned by A. He set the policy to begin with, and he gives the URL, that policy server. Then what the B is supposed to do, B is trusted to actually go and check the policy in the policy server before processing the data. So it's a trusted environment. B is trusted to do this. And then, he goes in step 3, he goes to the policy server. He says, hey, I got this data ID and I got it from A, origin ID, right? He knows because the data ID goes, because he's going to the A's policy server. Remember, he's not going to another general policy server. And then he says, I have the data ID. My name is B, processor ID. And am I allowed to open this data, use this data? And then because it's a yes or no, and then he gets used this. Right? Very common, we've had this type of thing long time ago, digital rights management, right? I send a photo of my daughter to somebody, and then I say, look, you can open this photo, but you should not be able to forward this photo to somebody else. And I trust the guy because he may forward it, she may forward it, but I trust it so that he looks at the photo, but he does not forward. This is a very common example of this data-oriented policy. And we can add lots of complications, like make it secure and stuff like that. And a very simple first step in the security protocol, you will say, yeah, I'm going to send the data, but I'm going to encrypt the data. That's the data star. A encrypts the data, and then A sends it to B. Again, B now says, I have this data ID to the A's policy server, and then says, okay, here is my public key. And then the policy server says, okay, yes or no, fine. But then it provides the key to unravel the data star, and this key is given using encrypted under the public key of B. So, very simple protocol, and we can use timestamp nonsense and make it secure, all sorts of analysis we can do this type of protocol. But this is just A to B. But in the internet, what happens, as I said, A to B to C, and not only A to B to C, but also B might take some data and modify it. And when B modifies the data, it becomes data dash. So the policies associated with data dash might be policies of A, plus policies that B might have as well. So it becomes complicated, yeah? So we can have, a chain of this thing. And now you can say, oh, B is in the same organization as A, but then that gives you something, domain. Or then you can say, no, B is in a different organization than A. Then you can have a hierarchical structure, federated peer structure. You can make this problem as, the real world, it becomes quite complicated, this type of thing. The only other thing I have not mentioned in the slide is the DTP record. I mean, what I'm just saying is, instead of saying, the previous slide, I had the URL as the policy server be distributed. Now, sent along with the data. Here now I can use the domain name server to store the policy server so that B knows where to go to find A's policy, server. So, and this type of thing, we would need some sort of a repository. So this but the main essence I want to convey is it is about before it is using the data, it is checking the policy of the data owner as to what it cannot do with it. And B itself, in this case, is a trusted agent. If it is not trusted, then the whole thing falls apart. So that's why the trust association with the agent is important. But in general, if I may extrapolate from here, we need a secure coupling mechanism between the data and the policy, right? That's got to be securely coupled, and securely coupled means by signature, encryption, so on and so forth. Then there is this processing agents. We need to define our trust model as to which agents we trust, which agent A trusts, which agent B trusts. They are not the same, right? So we may have a policy with respect to that. But the most important thing is we need these two additional infrastructure component, which is policy to data mapping and data to policy mapping. This does not exist per se by default in the internet as of now. That is the problem. You could not answer this question previously. Where is my credit card or Aadhaar card now? If we have this in the infrastructure, just like we have a domain name server, the routing server, all sorts of servers, if we have these two types of servers, and as I said, they are dependent upon the originator, the receiver, these policies associated with the originator with respect to the particular data types and so on. So it's not as it has got different data structures compared to the domain naming server and the routing server, but we need these infrastructure components in our internet infrastructure to be able to handle data-centric security approach that can address questions like the one of tracking data. So what do you do? I mean, the next step is we can have a policy language to capture different types of policies. We can have composition, because I said A does something and then A sends the data to B, and then but B modifies something, sends it to C. C modifies the data further, sends it to D. When that happens, we need to be able to specify this updates, dynamic data evolution, the policies associated with it, and we got to compose them. But it could be quite rich. We can do that, and then we can solve different types of policies and different, we can be able, when there are cross-border data flow between different domains, between different countries, we would be able to specify these policies and evaluate them and so on and so forth. The example I've got here, a law enforcement official may not act on improperly obtained evidence, but if the same information was obtained through lawful channels, the official is able to act. That type of policies we can clearly capture, right, using data provenance constraints. So, but there is a lot of, excuse me, 1 second. There's a lot of work here which we have done. Now, from that problem of data tracking, now I want to go to the data access control problem, the data-centric accuracy. So what is the problem here? Typically, when you do access control, you say, a principal is authenticated, principal being user, application, service, device. And then once the data access, authenticated, and I give an access control policy, I can give access to my data, the application is often trusted not to leak the data. So the access control is often principal centric. Right? But really what we do want from a data-centric approach is the one here. Access control should no longer be solely on principal or application, but should be data-centric in the sense it is controlling data flows between applications. And that is the important thing. So for instance, if I have a medical data collected from sensors, when the data moves around, just like I had a tag, remember that tag I associated with it. Now, if I define a type tag, which says this is a medical data, then whatever policies that I write will be based on the medical data type, so that only the users who have access to this type of data will be able to do that. Again, this is access control policy. We have done this type of thing many times, but focus is on the type associated with the data, okay? Now, a typical example, in a practical world, what happens is, if you look at web platforms like Facebook and so on. In fact, Facebook, when a few years ago, you might remember the Cambridge Analytica at the time. That's one of the times when we started our work, about 7-8 years ago in this. What happened was third-party applications were taking data. It was user specified the policies, who can access the data and so on and so forth. But a third-party application, when it got hold of the data, it was able to share the data with somebody else, other data. That was the problem. It was the data flow between application was not controlled. And in some sense, the third-party application, the other problem was what it actually did was, because the third-party application was running outside of the web platform, such as the social media platform, often it led to data exfiltration as well on top of it. But really, it was the data flow between applications was not controlled. And now we know how to do this again in the security world. So, and that is, it's very old. We have so-called information flow policies. I'm sure you would have, Orange Book, the ITSEC criteria, the common criteria, the federal criteria, they all have these types of things, but it was in a different context of operating system. But we can use these models, the Bell-LaPadula model and Biba model, which talks about associating labels with data. For instance, typically you can associate confidentiality label, you can associate integrity label, but they are associated with data. Then you can say, write policies as to when data can flow. For instance, this is what happens even if you take a Windows operating system. This started happening around 2007, 2008, around the time Windows 7 model. Windows 7. So what happens is, the browser, internet browser application was typically of low integrity. So the integrity label was lower. So therefore, it was, even though it had secure access control, gave the right to be able to write data into the registry, for instance, which is at a higher integrity level, even though the access control, the normal access control in the Windows operating system gave that, this integrity mechanism, by adding this integrity label, it prevented Internet Explorer to write data into higher security, higher medium or higher level integrity objects. This is the first time this type of thing was pretty much employed, as far as I know, in a commercial context. There are a lot of it in the military construct with respect to Bell and Biba model, the operating systems world, but it became pretty much commodity level at that time. So the typical rule here is, you will say the lower confidentiality can, information can flow from an application A to application B if the confidentiality label of A is lower than the confidentiality label of B, and if the integrity label of A is higher than to the lower integrity B. So it's always, you can write up in confidentiality and you can write down in the integrity. So you got to remember that rule. So it's duality. So that's the type of policy rule we will have with respect to tags associated with data flow. If you do that in the application world, we will need some additional, we need to make sure other operations like adding the label, removing the label, that type of operations we would need. We would also, we would need these meta operations. But then once you have got that, then you can define a context. What is the context? Is the entities with the same labels. If I have an application which has got this set of labels, confidentiality label, an integrity label, then I can define a domain for this based in terms of this context. Then I can write the policy. Flow of data between application A is allowed to application B if this rule is satisfied. That's in a nutshell, that's how it works. And now, but there are problems with respect to, what this will mean is you will always have flow of data going into more constrained domain. And in order to, in practice, you will need some additional operations to make sure for meta policies to modify the labels as well, declassify. It is not important for me to go through all these things. It's not important. What is important is we can write meta policies with these operations, and which will ensure that the data flows between applications can be controlled in a particular context. So I'll give you a couple of examples to so that you get a feel for this. So let's say a requirement is medical data must only be stored in encrypted form. So in order that to happen, what do we need to do in the system? We need to make sure that the database in which the medical data is stored is able to accept appropriately labeled data. So that needs to be changed. We at the moment, we may have a current data system may not have this, but we need to, whatever policy we are writing, the labels we have, we need to be ensure the database is set up like that. So that encrypted data can flow into that. So it can accept labeled data. But then we also need to make sure that the data gets encrypted. And this is where the endorser has to make sure, what does the endorser do? Endorser ensures the integrity labels to say that, endorser changes the integrity labels to ensure that the encryption function has been applied. Similarly, that if you take the next one, medical data can be used for research purposes only if the consent of the owner is obtained. So there is a tag which says the consent is obtained and the data is anonymized. So we need to have a tag consent is obtained. We need to ensure a function that does the data is anonymized. And then we need to make sure that the declassifier transforms the labels accordingly. So if that is done, then the database is set up to receive it. So this is the way where we can express and enforce policies which would allow application domains to handle sensitive data meaning integrity, confidentiality data. And this controls the flow of data, not the container. Right? Container, it says, oh, the data is stored in this file, I can access this file or not. But this says the data in this file, can it move to this one? Data used by this application, can it move to, that's what this controls. Now, the last bit of my talk, I just want to touch base on one other idea. It is still concerned with data-centric approach, but it is primarily to do with storing data in cloud in such a way that it only allows the users with a certain policies to be able to access the data. Let me explain this first, just a minute. Let's imagine, we have got this diagram here. So there are the users, there are two types of things. One is a data owner. So let's say I write my patient record into the cloud, okay? That is, I'm the data owner. And then the user who wants to look at my patient record. Here, the difference is, it is my data record, my patient record is encrypted. When I store it, it is encrypted. The cloud, as soon as it leaves my laptop, it is encrypted. So the cloud provider has only encrypted data, right? It is not that it is encrypted in the cloud. It only has encrypted data. So now I write policies. For instance, I might write a policy says, okay, the data, my patient data can be seen by this consultant and by my wife. Now, so the cloud provider will not be able to see the data as well. So that policy has got to be evaluated by the cloud and operated on encrypted data without decryption in such a way that my wife and consultant will be able to see the data, but nobody else will be able to see the data, access the data, view the data, including the cloud provider. So what it does is, so policy-based message, okay, let me now read this. Policy-based, not this one. So what it does is, it's a way of combining cryptography with access control. This is slightly different. Previously, when I talked about metadata, I did not operate on encrypted data, right? Now I'm operating on encrypted data. When I operate on, it's not homomorphic function, right? Not computational. What it does is the policy enforcement is done on encrypted data. It is not arbitrary operations. It is only my policy enforcement. So what is happening is my data is encrypted to different roles. In the case of, I can apply any access control, but I'll just say role-based is common. So my data is encrypted to role or roles. That's why I said my consultant and my wife or a family member. Data owner encrypts the data in such a way that only users who satisfy the role-based access policies specified by the owner are able to decrypt the data. That is, only the family member, my wife, and the consultant in the particular hospital would be able to decrypt the data. If the data is stored in the cloud provider does not have the appropriate roles, he will not be here. The cloud provider will not be able to decrypt data. So it reduces the trust level on the cloud provider like Amazon, Azure, whatever it is. But at the same time, it gives, and the beauty is how this it is combined, it is intricately, it is not separate, two separate systems, cryptography and access control. It is an integrated system which we have developed. And we actually trialed this with the patient record in new health record system in Australia with the different types of hospital administrators, emergencies, also different multiple roles and so on and so forth. And there's a whole PhD thesis here, and it's got the new technique is called role-based encryption, and then it has sorts of probably in terms of performance, the beauty is it's got an efficient revocation scheme, and it's got a constant. It's lots of nice properties like constant size, cybersect, and so on and so forth. But those are all crypto properties anyway, which you needed for that. Now, what are this type of work has got applications in other sectors, other areas as well. So I talked about secure cloud data storage with respect to new health records, but also you can secure data sharing in a consortium. Let's say if you have 5 banks, in a consortium, and each bank has got their own data and their own policies. So a bank 1 will be happy to provide the data to bank 2 in an encrypted form associated with its policies, if and only if it is guaranteed that bank 2 will enforce, will only be able to view bank 1's data if and only if bank 1's policies are satisfied. So this is the way, and this is, so we've all done further work, and that's also been, whether we've applied it into sort of, streaming services as well, like Netflix and a variety of them. So there are lots of application, but the idea is still, the focus is on data. So let me conclude. And what we have seen, the first one, we said, okay, with respect to data-centric security, what it means is data is the primary concept. So the policies are specified on the data rather than on the container. By the way, it's also true in networks world, and this is also pretty old in some sense. Our work was on access control in the networks, but NDN, named data networks, you might have heard of, which started somewhere 2009. In the networks, typically you have IP, you control the sessions and the channels by IP address, MAC address, and those stuff. They're all addresses of containers, not the data. Whereas if you start working on the data itself, which is where we did our streaming service, because then what happens is the movie which you downloaded from the Netflix server, the identifier is for the movie. We are protecting the actual movie, not the container of the Netflix. So then the movie can itself be stored in different routers. I don't need to go back to the Netflix server to be able to download the parts of the movie again next time when I need it or when another user needs it. So it has got all sorts of, it's part of like your CDN, ICN, content-centric content data networks, information-centric networks. These are all based on that, but our work was on the access control for this. So data-centric approach has got multiple areas where it's relevant. But the approach is we need to attach tags with data, define the policies, define how the agents can process the data. We need to write trust assumptions and then write protocols and make the system so that data is the valuable content. So data is the new currency. But there are lots of challenges. Challenges are data visibility, because organization might have different types of data, how much of the visible, and the categorization of data, dynamic data evolution. So as the data gets updated, the policy changes. So and then if you have legacy system integration, which you always will have, these are all practical issues you will deal with. But also regulation is an issue. Regulations keeps changing. GDPR is one, which is although it's big, there are aspects of it which you can capture, but it's very useful for when you talk about data flow between countries or between organizations. But demonstrating compliance is also another issue which is there. Anyway, so I just wanted to introduce this idea to you, the data-centric approach. I'm sure some of you would have seen that, but we've been doing some work in this area. And with that, let me conclude my talk.
Any questions? Okay, so I have a question. So in the role-based encryption, the encryption schemes are traditional, only that it has the role has to be checked, and if the role has credential, then only the decryption will happen. Am I
Yeah, but
understanding
they are
correct?
not exactly, but they are not two separate systems. It is not I check, do the encryption, I do the role check. They are not decoupled, they are integrated. So the encryption scheme is integrated with the role. The role has the key. It is not that I first check the role. Hey, I got the role. Oh, this is John. John is a project manager. That's tick. Then I go and the key, I do the decryption. It's not like that. Okay, that system has got other issues. That is what I mean by two systems. This is what the whole area, you might have heard of this in Stanford. They did I think mid to late 2000s, it called attribute-based encryption. Have you, that attribute-based encryption is, so, and this is similar, the role-based encryption is similar, but it's based with roles rather than attributes. Attribute-based encryption is like, why I'm telling you is that you might have come across that. Attribute-based encryption, let's say, instead of saying Vijay can decrypt this data, they will say like, if a user is wearing specs and he happens to be an Indian, he can decrypt it. You see, is the attributes associated with the principles. In this case, it's a role, but the role gives you the whole things of inheritance, hierarchies, which attributes don't have. So that's why we can do much, much more powerful things with role, which are relevant for enterprises. Attribute-based encryptions, you will do that for IoT systems, whereas role-based you will do for enterprise systems. So anyway, but answer to your question is, yes, what you said is correct, but how they are integrated is that's where the nub of the problem lies. That's why it is called integrating cryptographic techniques with role-based access control. It is not saying I do role-based access control, then I do cryptographic. It's not like that. Yeah, there's a whole thesis. So if you want to read about that, I can. I mean, if you Google, design of RBE schemes and their implementation. If you just, I mean, the PhD student was Lan Zhu, SZHOU, Lan first name, and he was my PhD student, and in fact, it won an award for this, the one when we did the New Health Record. But you will find about 10 papers explaining the various things what we have done.
Sure. Thank you, Professor. There is one more question.
Yeah.
Mike.
Presentation from you. I was actually on that Australian Department of Health and Aging electronic medical records project, and so we were working on that, trying to associate all the agencies and the doctors and the Medibank Private and all that associate agencies. And one of the key areas was trying to establish a kind of a data glossary, and the data was metadata driven, pretty much on physical business metadata, technical metadata, operational metadata. So everything that the data was consumed, as you have mentioned, that it will be data centric, but however, when the analytics are driven, they're tagged, and based upon that, the data associated with that will be processed. So how do you take, when you are referring to data-centric and metadata-centric, how do you differentiate that? That is one aspect. And what are your thoughts on the recent Medibank private data breach? I was one of the victims there. And so what are your thoughts on that? Thank you.
The first one, the first one, what you said, the associating tags to different types, whether it's technical tags or my business tags, different types of tags, and having a language and writing policy rules is exactly this. Right, that is exactly that. But what it gets complicated is you always have to, when they do the implementation, they revert back to usually this container-based approach. Although they use the tags, the policy language and the way they evaluate it is they go back to the traditional access control. That's one of the problems I've had. So you got to maintain the true nature of data-centric all the way through, not only in the specification, but also in the evaluation and enforcement. But when it comes to Medibank, uh, you're right. In fact, after the Medibank, there was much interest in this project, because this project got the award in about 2015, 2016. We worked with, at those days, it was called PCEHR, Patient-Centric Electronic Health Record, with the Department of Health, Federal Commonwealth. But then it turned into New Health Record. But they still haven't implemented this. So as of now, PCEHR does not have this. They have a traditional access control, role-based access control. As they have to store the data in plain, and some of them may be encrypted, but exactly like, if you're the patient or you're the patient's relative, something like that, they will do authentication of the front end, and authentication will check your ID and will check your role, and then it will get to your key where you will decrypt it. But at the moment, most of the data in the patient, new health record, as far as I'm aware, it is public. It is the plain. It is not encrypted. So when the Medibank thing happened, there are a few issues came about. One, okay, why did Medibank store this data for such a long time? So there was a storage policy issue. How long? Why do Medibank collected data which they don't need? They collected some data, different types of data, which data. But then the issue was, you see, if Medibank had encrypted the data in the cloud they provided, then the data breach would be minimized, because even though there is a leak, the guys, the hackers would not have got it. But the problem with these things is, when you store the data in encrypted form, you have to enforce all the policies on the encrypted data. So for instance, you say a patient, okay, I'm a patient, I have my Medicare data, I want my Medibank, Medicare data stored in, medical data stored in Medibank, I want to give that to another provider. Let's say I write that. When I write that, the other provider should be, this is a legitimate policy, the other provider should be able to view my data, access my data, even though the data is encrypted, but it remains encrypted until it reaches his computer. So that is the problem. So when you decouple the two, what happens is you do the access control on one hand, you do the cryptography on the other hand, but often what happens is, in the cloud itself, it is in plain somewhere. But as far as Medibank happened, they did not have encrypted data. So the breaches which happened were really plain text. I got breached by recently by Qantas. Right? Qantas made happen. Again, they don't encrypt the data because it has got computational issues. That's why the schemes we need to adopt here has got to be performance efficient. That's why we did a lot of work, extensive computation study to show that ours is efficient. But efficient, true, compared to other schemes, but still it does have an overhead. And unfortunately, at the moment, this is not implemented in the systems like Medibank. It's implemented in prototypes, but it's not implemented neither in Medibank nor in Qantas, type of things. Yeah, that's probably the why.
Thank you. Thank you, Professor.
Thank you.
There is one more
Thank you
question.
very much for the question.
Sir, just one more question.
Yeah.
So this is more of a comment rather than a question. Actually, the idea of DTP records getting added into the DNS and protecting the privacy, that's actually a very welcome move. And I feel that at the gateway level or the enterprise entry point itself, we are able to do it, manage it well.
Yes. Yes.
So any standardization efforts of that particular record, because DNS is fully standardized. So that's my...
No, there is no. In fact, as the previous questioner there are some different sectors trying to do some work on it. Healthcare is probably the more, there's some work happening, but I'm not recent, but to be honest, thank you for your question. Honest, I'm not involved in the recent standardization activities. There may be some, but my recollection is about few years old, 4 or 5 years old. At that time, there were different sectors trying to do something. Healthcare was the one that I was primarily involved in. Financial has got some things as well I know of. But this type of idea is still not there in the to the extent standardization will happen, because this the problem at the moment, so let me give you, I don't want to throw some names, but Tim Berners-Lee is also interested. He created a company in 2019 around that space to do some similar type of work, creating these types of data tags and policy language. And they wanted to actually propose, there's a paper called Data Algebra he wrote in 2018, which is a short paper. But really, answer to your question is, as far as I'm aware, there are ad hoc activities happening, but I do not know of a standardization for DTP record which should be included in something like a DNS. In fact, I would love to create, this is what I've been saying to different people, but it is not getting traction. We need to create this policy to data, data to policy. And for that, you need to be able to standardize something, infrastructure component, and we can merge it with DNS exactly the way, but it is not there as far as I know.
Okay. Thank you, Professor. Thank you.
Thank you.